Hi, everybody. I'm very pleased to introduce Katie Dagon today. Katie was my mentor when I was a visiting fellow at NCAR a few years ago, and she's a wonderful, dynamic person to work with. I'm glad that she could join us. Katie is a climate scientist at the National Center for Atmospheric Research, NCAR in Boulder, working in the Climate and Global Dynamics Laboratory. Her research focuses on modeling the impacts of climate change on land-atmosphere interactions, climate variability, and extreme events. She's also interested in machine learning approaches to climate science and modeling. Katie is passionate about open science and helps lead the NCAR UCAR Earth System Data Science Initiative, which she's going to talk to us about today. So thank you for joining us, Katie, and take it away.
Thanks, Lily. It's really nice to hear your voice. Thanks, everybody, for being here. Casey, Allison, for helping set up the logistics for this. So yeah, as Lily said, I'm a climate scientist at NCAR, but I'm going to talk today more about some of the organizing around Earth system data science that we've been doing at NCAR UCAR. But before I jump into that, I thought I would just have one slide about myself and my research, just to give you guys some context about where I'm coming from and how I got into this data science work. So I'm a climate scientist and a modeler. I've been at NCAR about 6-7 years. I've been increasingly interested in the open science space. Some of my research interests center around machine learning for climate modeling, which is kind of a vastly growing field, which has been really interesting to be part of. So some of the projects that I'm working on for both land and atmosphere modeling have to do with understanding uncertainty in models. So using machine learning to emulate and calibrate land models, and also some work using machine learning to detect extreme events in climate data, which is what the animation is showing, and thinking about extreme precipitation and predictability in the future. So that's just a little bit about me. And as many of you might know, climate scientists, climate modelers have to deal with a lot of big data problems. So that's sort of one of the ways I came into thinking more deeply about this Earth system data science space. And just to sort of get everyone on the same page, and it's kind of an interdisciplinary audience, which is great. This is my sort of climate modeling 101 slide. So, for us at NCAR, when we're thinking about climate models or Earth system models or global atmospheric models, that sort of use these terms interchangeably, we're thinking about large computer programs that try and simulate, to the best of our knowledge, global atmospheric, land, oceanic processes. And we can use these models to study changes at different timescales, explore interactions, test different decisions, and understand our natural systems. And then specifically, because I'm going to use a few examples with a particular climate model, I just wanted to give a quick introduction to the Community Earth System Model, or CESM, which is a model that we spend a lot of time thinking about developing at NCAR with the university community. And so when you sort of dive into the specifics of these models, they're usually broken into their different components. So atmosphere, land, ocean, ice over land and ocean. And there's various, external inputs that you can feed into the models and look at the interactions between the components. I like to use this diagram from Alexander and Easterbrook. It's a little bit old, but they intentionally designed the size of these bubbles to scale with the number of lines of code in the different components, which I thought was kind of a neat way of showing it. Sorry about those bars at the top of the screen. I wonder if I can use those. Go. I'll just do. I want it to be distracting. Oh, okay, maybe I can't get rid of that one right now, but so speaking of lines of code, the most recent version of CESM has over 2 million lines of code in it. So this is a large computer program. This is a fairly significant community of developers, anywhere between 50 and 100, both folks at NCAR and external university national lab contributors, probably on the order of hundreds of users worldwide. It's sort of difficult to estimate that, but we have annual meetings that draw hundreds of participants in person and online. And I think very importantly, this model is publicly available on GitHub. So that's how contributions are handled. That's how sort of, bugs are handled in the development process. So it's been really interesting to observe this sort of large scale community development process that's done quite openly. But we have some challenges when it comes to thinking about Earth system models in the future and how we prioritize development of Earth system models. And I sort of like to think of this on 3 axes. So this diagram on the left is sort of showing how we are thinking about both changes in resolution of models, meaning the size of the grid boxes. So the ability to represent finer and finer scale processes with these models, but at the same time also complexity. So adding more process representation, whether it be atmosphere cloud processes, things happening over the land or the ocean. And then we're also sort of pulled in this direction of wanting to run longer and longer duration simulations, and also ensembles, which I'll talk about in a few slides. So many sort of realizations of different climate scenarios. And so sort of pulling in all 3 of those directions is increasing the computation and the data sizes of the models themselves, and what we sort of have to analyze as output from the models. And then the figure on the right is showing the sort of trend of projected data and compute. And this is sort of both pointing out that there's, we're creating vastly more quantities of data, but we're also seeing this sort of negative trend in data per computing power, which is, I think, the best of my knowledge, sort of pointing to the lack of the compute to be able to handle the large quantities of data. So this is a big data problem. When I think about my workflow, and I think many climate modelers sort of approach their workflow in this way, I sort of think about it in 3 components. So we start on the top left, designing simulations, which has to do with maybe selecting the components of the Earth system model that you're interested in simulating. Do you want to look at the whole system? Do you want to look at interactions? Do you want to focus on the atmosphere or the land? How long do you want to run the simulations for? What's the spatial scale? What level of complexity? So there's various design choices that go into this. And then if you go to the next step, running simulations, which involves a lot of high performance computing resources, it involves a degree of software engineering to sort of manipulate the code to the way that you want to configure the model and get it running successfully. And then the third part of this sort of flow here is analyzing the output. And that's sort of what I want to zoom in on for this particular example, which is how you get from actually the running of the simulations and the output to making a plot like this. And you could consider that with any data source, right? It's not just climate models, but how do you get from a large data set to doing the particular analysis that you want to do or making a particular visualization? So I'll just show an example with the CSM large ensemble. So this is, I mentioned ensembles before. This is a big data problem. This is a set of simulations that had a bunch of different realizations to try and sample atmospheric variability. So if we just consider data from a single variable, this is kind of showing a 3D ocean field. So you can think of it as maybe sea surface temperature. So it's 3 dimensions because it's 2 dimensions in sort of horizontal space and then depth in the ocean, but then also the 4th dimension, which is time. So that's sort of the NT, and that's monthly output from 1920 to 2100. A single field is already 60 gigabytes at this sort of resolution that the model was run. But then, as I mentioned, with the large ensemble, we have 35 different realizations of atmospheric variability. This is sort of getting at the chaotic nature of weather. So you perturb the initial conditions to sample the sort of spread of variability. So that gives you a single variable that's 2 terabytes. So this is a big data problem. This creates challenges to being able to, again, go from our model output to our analysis or our visualizations. And so this sort of gets to one of the challenges that I want to speak to, which is data wrangling consumes a lot of our time. There's this sort of axiom from data science, the 80-20 rule. Data wrangling consumes 80% of scientists' time. And of course, we'd like to be doing way more of that, spending way more of that time on science and not just figuring out how to wrangle our data. I think another challenge we have is that people tend to develop their own solutions for problems and not necessarily use existing code. Maybe they don't know about it. Maybe it's easier to just sort of brute force. I know I've done this many times. So we have challenges associated with how we can share our code. Another thing we're thinking about a lot, I'm thinking about a lot in my research, is how to prepare for these emerging ML and AI approaches, techniques. And I think it's all sort of connected to these data analysis problems. And then perhaps a more broader challenge is how to democratize access to climate data. So there's, we know there are barriers to data access and compute for a variety of reasons. A lot of data is stored locally on, internal HPC systems. That's not a very accessible way of getting at climate data. So we also want to sort of think about this in terms of the infrastructure and how people access resources and data. So with those challenges in mind, the group of us at NCAR started thinking about how we sort of approach this problem and how we could think of it more holistically across our organization. And so at NCAR UCAR, we have a variety of different domain sciences, applications, water, weather, air quality, climate, sun and space weather. And while we might have different goals, a lot of times we have the same sort of means of analysis of getting to how we want to process our data, how we want to visualize it, how we want to understand it. So using combinations of theory, observations, and simulations, we want to sort of take that application and use data science to build abstractions. And I'll talk about what I mean by that in the next slide. But sort of more broadly, I think this has important strategic relevance for being able to do interdisciplinary community projects, actionable science, convergent research. These are all important strategic priorities for NCAR and NSF. So what do I mean by building abstractions, right? So we have our different goals, same means. Some of the specific things we can think about when it comes to, sort of making our science executable, thinking about the analytics itself as a science. I spoke to this before, but we often have to deal with multidimensional fields, right, in space and time. We'd like to have something where we have self-describing formats so we can use, labels of variables to sort of manipulate data. We have to deal with a lot of different grid objects and regridding and remapping. That's a common problem across, observations and modeling data sets. We have different, methods that probably have some commonalities across these different science applications. We want to aggregate our data. We want interpolate it, do some regression. And as I mentioned before, we're thinking about machine learning as an application, and I think really importantly, visualization too. So not just getting to that plot, but how you're building that plot is an accessible way of understanding the data. What are the best approaches? So again, this group of us sort of started thinking about principles on which to build this approach. And this one relates to what I talked about before, which is, don't discount existing solutions. So avoid the not invented here syndrome, which means, try and leverage existing code and existing workflows. Related to that is sort of, okay, write new code as a last resort, really try to reuse. This sort of visual of the chain across the keyboard always makes me laugh. But it's hard, right? I struggle with this myself. If we can design code that's modular, I think it helps with those challenges of making it easier to add in new features as you build something. And then again, more broadly, we want to do this in a way that we're ideally building inclusive and diverse communities of practice. So we're leveraging lots of different ideas and different backgrounds and approaches. So that led us to actually form this initiative at NCAR UCAR called our System Data Science Initiative. And our vision is to increase the effectiveness of our workforce to essentially get people to talk to each other about their analytics, promoting that collaboration, which will hopefully help deliver these solutions that can be more actionable, impactful to the community, and really think about how geoscientists are extracting these, working with these big data sets and synthesizing information. So there's a variety of sort of facets that go into that: data science, data engineering, a lot of software engineering, you have observations and modeling tools. So how does this work in practice? So our approach has been to cultivate a community of practice where we encourage open development, reproducible science. We have, training and education efforts, but sort of fundamentally community building. Like I said, it's really getting people to talk to each other is a huge part of this, getting people to collaborate, and think more about how they can, reuse different parts of folks' workflows. So we have an online presence, and I'm happy to share these slides if anyone is interested in our sort of websites. We've got an email list, Google group that we welcome anyone to join, not just internal folks. And then to give you a little bit of sense of the background, like this vision took a while for us to develop. We didn't just get there from day one. We formed about 3 years ago, so late 2020. We actually started in the lab that I work in at NCAR, Climate and Global Dynamics, which is one of 6 to 10 lab centers programs across the organization. And at that point, it really was thinking about how to bridge data science with earth system science, motivated by these big data sets, these large climate modeling problems, but also to provide leadership roles for early career scientists like myself. So we very quickly expanded to include the computational lab at NCAR because we realized we needed the expertise that those folks had on a lot of different topics. There was a quickly evolving need for Python support, which I'll talk about in a few slides, but also things like machine learning, cloud computing, data storage. So with that sort of initial group of, I would say, 5 to 6 people, we started developing this vision statement in late 2021. And then we really put a focused effort in expanding to the other NCAR UCAR labs and programs, and that's continuing. It's a very grassroots effort. We have very little formal support in terms of funding. So it really is sort of getting people who are passionate about this topic and willing to spend their time and see that hopefully it benefits their own work by being part of this. So we established a formal governance structure earlier this year. I'll talk about that on the next slide. We have a leadership committee and working groups. And then we're also learning a lot from the Pangeo community. I don't know if folks are familiar with Pangeo, but I'll talk about that as well. We're sort of trying to develop a Pangeo-like community of practice at NCAR. So in terms of our governance, we have a leadership committee, which sort of consists of many of the original members. And also as we've tried to expand to the different NCAR UCAR labs, we have, I think, about 6 represented right now. But we don't have everybody yet, right? It's still sort of a slow process to sort of train people, get people interested. And so the leadership committee provides sort of general oversight and also helps define the working groups. And right now we have 2 working groups. One is the community working group, and their sort of flagship effort is to organize and plan our biweekly forum, which is like a seminar or like a discussion group. But they also advocate for training events. They help manage the office hours, which I'll talk about in a few slides, and the blog. And then we have an events working group, and they help plan, sort of special events, whether it's hackathons, collaborative coding. We're trying to have an annual community building event every year, and they also help with relevant tutorials. So I mentioned Pangeo. We're really trying to build off the Pangeo effort. Pangeo is a community platform for big data geoscience, and it's really not one specific tool or package, but it's kind of leveraging the open source Python stack for Earth system analysis. So maybe some of you are familiar with things like Jupyter for interactivity, X-ray we use a lot for, again, labeled multidimensional data, Dask for parallel computing, and then sort of a newer, the more emerging thing is producing data catalogs, for example, the CMIP6 archive, using tools like Intake and ZAR, trying to put data in the cloud. So I recommend checking out Pangeo if you aren't already familiar with it. They have a lot of active events. They're going to have a pretty nice presence at AGU this year as well. So we're, very much inspired by their efforts, and try to use them as a model for our internal community practice. Another sort of fundamental, transformative, I think, aspect to our work has been the use of Jupyter hubs. Even in the time that I've been at NCAR, I think this has fundamentally transformed how people do their science. So what I mean by that is, when I was in grad school, I was doing a lot of things through the command line interface. Maybe I opened MATLAB, maybe I opened RStudio, and I used those tools. But now you can log into a Jupyter hub and have access to the HPC file system at NCAR. You can create a notebook instead of a shell script. You can run things really interactively. And this is how students are learning how to do their analysis. And I think that's fundamentally different than the way it was even 5 years ago. It's also how we teach things like, the annual CSM tutorial is now moved towards Jupyter notebooks instead of the sort of traditional shell scripting. There's still some of that, but yeah, it's been really interesting to sort of observe that and see how people are learning and doing their analysis. Another fundamental change for NCAR, and I mentioned this briefly before, was the pivot to Python. So in 2019, NCAR Computational Labs sort of had this official decision where they decided to switch from supporting the previous language, which is called NCL, the NCAR command language, which is sort of rather specific to climate model analysis and CSM in particular, and pivot to Python. And so this was a really big deal for a lot of users of NCL, people who were unfamiliar with Python, very apprehensive about sort of moving over. And because this happened sort of right leading up to the formation of our initiative of ESDS, this was a huge part of our sort of getting started. And a group called GeoCat, which is the Geoscience Community Analysis Toolkit, was established to help port some of the previous NCL capabilities to Python, but to do it with some of those Pangeo packages like X-ray and DASC, and to do it more openly so that the development is explicitly seeking user engagement. Yeah, so this was a big part of sort of our starting out, was helping to get people comfortable with Python and sort of establishing common tools that can leverage the old code, but do it in a way that's a little bit more open. And then just one project I wanted to highlight is Project Rygen, which is working on how to deal with unstructured climate grids, which again, from the climate modeling side, is kind of an emerging issue. So if you're interested in that, I encourage you to check them out. So relative to that, so supporting Python learning was a big part of our sort of initial focus with ESDS. We had regular Python for Earth Science tutorials held from 2020 to 2022. And those were all sorts of topics like just getting started, advanced plotting, X-ray, CartoPy, these specific geoscience packages. And so all these materials are online, and there's an archive of the recordings on YouTube if anyone is interested in checking these out. But this sort of led to Project Pythia, which is actually now the educational arm of the Pangeo project. And so they've sort of formalized these tutorials as more of a training hub for geoscience Python. They have things like tutorials, videos, examples, and cookbooks, which I'll talk about in the next slide. And they have this concept called Pythia Foundations, where they're trying to build foundational skills for scientific Python. So there's a lot of great resources through Project Pythia, and it's been nice to see the sort of transition from, we had these sort of set of tutorials that's now become more formalized and more established and formally connected to the Pangeo project. So this is just an example of one of the cookbooks through Project Pythia. This is the DASC cookbooks of parallel computing. And so it looks like a Jupyter book. It's a combination of text and code, and you can sort of run through the steps incrementally, test them out on your end, sort of prompting with questions throughout. But I wanted to flag that this cookbook was developed because there was a tutorial at NCAR on using DASC on the high-performance computing systems, which in turn was motivated by discussions that we had during the previous ESDS annual event, right? So it's nice to see the connection between the community says, we don't understand how to use DASC effectively in our workflows. That leads to a formal tutorial that leads to an actual permanent home online for of resources for DASC. So it's been really nice to see that sort of workflow. And we hope that we can repeat that for other topics of interest. So in terms of getting help, we have a variety of resources that we support. One is office hours. These are sort of one-on-one appointments that you can schedule with different community volunteers, and you can sort of select the person who maybe has the background for what you're interested in asking about. So we have sort of a website portal for that, and then it's like you match the availability with calendars. I think it's a really nice system. Julia Kent has set up, she's at the top there. I made a quick, very quick analysis of the topics that come up in office hours, because the office hours folks are good about sort of logging what questions they get. So, and this is from the past maybe 18 months or so. So the majority of the questions are about X-ray and DAS. So again, coming back to those Pangeo, Python, open source packages for analyzing data, hence the DAS tutorial and things like that. And then the next largest query is about, it's cut off, but it's environment management. So in yellow there, so that's like using Conda for Python packages and things like that. That's sort of a persistent issue with how to install your own environments on the HPC systems, use them on the Jupyter hubs. So we see this come up a lot. And then there's been a number of questions about plotting, visualization, regridding in the green. So that's related to Project Rajan that I mentioned, and a couple of, also to miscellaneous questions. Another nice feature of the office hours is that due to the success that we've seen on the EDS side, NCAR's HPC support, which is a separate group, adopted this model. And now when you go to the office hours website, you can select either ESDS office hours, which is kind of these analysis type questions, or if you need specific help on the consulting side for the HPC systems, it's all integrated as part of one system, which is really nice. Another way of getting help that has worked really well for us is using a platform called Zulip. Zulip is kind of like Slack. The scope is that it's mostly internal NCAR UCAR folks, but we do also invite external collaborators on there. I think some CU folks are on there. It's sort of an asynchronous discussion forum like Slack. So you can ask questions, respond to queries, announce special events, things like that. What I really like about it, what I think is powerful, is that it's the community helping each other. It has a searchable feature such that if you're like, I want to know something specific about DAS, I think this question was asked, but I can't remember, you can sort of search for that and see the record of question and answer. And in that way, it serves the silent majority. So what I mean by that is most people might not feel comfortable asking questions, but at least everything is in a way that's recordable, and you can go back and look at the responses. So you may not, when you respond to a question, you may not just be helping that one person, but a lot of people in the future. So these are just some of the channels that we have, different Python-based analysis topics. And then this is just an example of a sort of back and forth we had about how to shift longitudes in Python with X-ray. So a person asked this question, and then maybe 20 minutes later, someone responded with, you can embed code, which is kind of a nice feature. Like, this is how I do it. And then I sort of pointed out there's a couple of HardPy functions as well that you can use. So this has been really successful for us to sort of put this platform out there, have the community help each other. In terms of sharing resources, I mentioned we have a website. We have a blog which posts various topics, from anything from what I've learned about debugging, or specific analysis with the land model, or recaps of the SciPy conference was another blog post, right? So just topical things that then have a permanent home we can refer back to, and we're always welcoming posts from the community. We also have an FAQ which sort of tries to address some of these common questions, like how do I optimize reading multiple files with X-ray and DAS, or creating and accessing Conda environments, these things that come up quite often. I think one thing I want to note here is that because this effort started in the climate dynamics lab, and it has somewhat of a climate modeling bias to it, and that's reflective of the sort of active members in this organization. And that's why we're really trying to push for expansion across the organization, sort of a chicken and egg, right? Because you don't necessarily know the problems that those other folks are facing until you get them engaged. So we're definitely aware of that sort of, leaning of the resources, and trying to think about how we can combat that. Something that we did recently that I think is nice, I'd like to do this again, or I'd like to support this again, is, there was an event happening at NCAR, this hackathon, this Forces Knit hackathon over the summer, and they reached out to us and said, can you help us sort of get everyone on the same page for our hackathon? Do you have resources, or can someone give a presentation on coding practices? So Julia Kent developed this, relatively short, probably 15-minute presentation on introduction to the Jupyter Hub, thinking about notebooks and functions, elements of a Python package, contributing to GitHub. And I'm hoping that we can reuse these resources because they really are quite general. And again, as we see increasing use of Jupyter Hub and GitHub-based projects, I think it's helpful to have sort of a starting point for these types of events where people sort of get an understanding of the different tools and how they might use them. Okay, so my last few slides, I want to talk about building community, because this is really fundamental, I think, to this work. So I mentioned that we have this forum that's bi-weekly. So every other Monday in the afternoon, usually all virtual, but we just had a hybrid one yesterday because we had a guest speaker from the UK. So this is, often workflow demos. If someone has an analysis tool that they've developed or they want to flag, we'll have them feature that, focus discussions, feedback on computing resources. So we invite the NCAR HPC team to come to these sort of on a monthly, bi-monthly basis, so they can sort of directly reach the community of users. So we've had a couple of recent discussions, GIS at NCAR, DAS, data science, caring for the data and data science. And we're welcome engagement on all topics, and external attendees and speakers are very welcome. So anyone from this community is very welcome. And you can sign up for the email list to get notified. Other ways that we've tried to build community. So we had in the spring what we very intentionally called a collaborative work time session. We did not call this a hackathon because at our previous annual event, we had a really interesting discussion about how some folks felt the word hackathon was a little intimidating, and they didn't necessarily feel like they had the coding skills to attend a hackathon. So we intentionally didn't call it a hackathon, but we sort of set up this half-day hybrid event that was a specific focus topic that was chosen based on discussions that had happened on Zulip in the forum. And it was a topic that we thought would have relevance across a variety of different groups at NCAR, again, trying to build those cross-lab connections. And so it was on unstructured grids. I mentioned that before as a kind of an emerging, analysis challenge in this space. And then we had a social event afterwards as well to sort of continue that community building. So hopefully we'll repeat this with different topics or continue this topic. And we're also having another annual event. So the next one is in January. External participation is very welcome. This is going to be a 2-day hybrid event. The organizing folks made this survey so that they can see what the most, desired topics could be for things like tutorials and discussion groups. So we're really excited about this too. Okay, so as I begin to close, I want to just reflect a little bit on this effort. I always say that ESDS is a work in progress. It's been a lot of trial and error over the past 3 years to figure out how to best serve the community. Some of the things that we've reflected on are the things I've listed here, right? So I think the Zulip platform has worked particularly well to have that asynchronous discussion, to create a searchable archive, to help people debug their code. About a year and a half ago, we actually rebranded what was previously called Work in Progress Talks to the ESDS Forum, because we found that, again, folks felt like they had to have a polished presentation to come to this event. So we really wanted to center it as a discussion group. We also switched the forum to primarily virtual to increase the engagement across multiple NCAR UCAR campuses. The tight timing of folks having to come to one physical location across town sort of led to that change. And then the office hours have come a long way too. So what I presented has been sort of an iterative process of getting to that specific platform in the way of scheduling and selecting people that you can chat with. It used to be a single Zoom meeting at a very specific time, bi-weekly, I think, that then a set of office hours volunteers would staff, people would join the Zoom call and go into breakout rooms. That wasn't ideal for anyone's schedule to have to sort of be in that place. Demand sort of fluctuated for the office hours over time. So this works much better to do this sort of on-demand scheduling. And as I mentioned, it's great that the HPC group is also sharing the platform with us so that people just have to go to one place. It's been also nice to see that the tutorials have grown from sort of the introductory Python data science to more complex topics, and that we're able to partner with other groups to develop tutorials. So it's not necessarily our group developing the materials, but it's more our group collecting the community input and passing that on to folks that can support more educational efforts. And I think our community continues to grow and evolve. And again, I'd be very interested to hear the experience of your communities here. Again, lowering the barriers for participation. What we see a lot is it's hard time and sort of awareness of this group. So we're trying to sort of grow as much as we can, but it's a slow process. Also, we deal with challenges with staff turnover and retention of software engineers. That's left us with sometimes gaps in our ability to maintain certain packages that have been developed internally. So that's been a challenge. As I mentioned, engaging other groups across the organization and advocating for awareness and support. Since we're very grassroots, we have very little formal funding, really trying to leverage what we can based on people's interests and hopefully recognizing that it'll benefit their work as well. So I think we've come a long way in 3 years, including getting started at the height of the pandemic, which sort of gave our effort an initial virtual nature, but we're trying to have more in-person events too. I submitted an AGU abstract on ESDS, which had 24 co-authors across 6 NCAR UCAR labs, including people who have gone on to work at places like NVIDIA, climate tech startups like Carbon Plan, Chorus Geospatial. So it's been really nice to see the efforts evolve over the years. And if you're at AGU, the session that this presentation is part of looks quite interesting. It's about flourishing science commons. There's a lot of great open science sessions at AGU this year. And something that's been important to me, that's been really nice to see is, people noting the resources at different meetings that folks have attended. I've had grad students say, I recognize your name, not because of my science, but because I responded to something on Zulip, which I think it's actually really nice to hear that. Okay, so this is my last slide. I just want to close by, asking the question, what can we learn from each other? I'd be very, very curious to hear some of the ways that you all build and maintain community. Are there things that work well or less well with your efforts? How do you advocate for support? How do we lower barriers to participation? And how do we think about sort of the future of open science for system science? So thanks very much for your attention. I don't know how the discussion usually goes, but I'm happy to take questions. And let me know if there's anything online too.
We got some applause online.
Not even sure how long Earth Lab has been around.
I can answer that question. I'm Jennifer Balch. Nice to meet you. Thank you for this wonderful presentation. So Earth Lab started about 8 years ago, and EASL started a year and a half ago. Yeah, and EASL was an outgrowth of Earth Lab. Earth Lab is really a university serving entity, and EASL is now a nationally serving entity. Under the larger banner of what we call environmental data science, but we also call it sometimes Earth data science. And I'm curious about the Earth system data science language and kind of how you landed on that too. I love these questions. I'd love to continue the conversation. One thing that surprised me in your talk, I kind of had this notion that the climate and modeling community were like super ahead of the game in terms of what we call environmental data science and open science practices, but the shift to Python in 2019, and that was a shocker for me. Like, that's so recent. I'm surprised that didn't happen like ages ago. So I guess one of the questions I have for you is, like, what are some of the challenges, even though like NCAR and UCAR have been doing this for such a long time? Like, what are some of the challenges that you see coming up in the next 5 years? Like, what are some of the big leaps and bounds that have to happen?
Data in the cloud, computing in the cloud. We're already starting to run model tutorials in the cloud, but access to resources, pros and cons, right? Like, don't have to set up an HPC account for students who want to learn how to run the model, but how do you get those, AWS resources? Is always a question.
Is that where NCAR is moving to AWS, or?
It's something that we've leveraged for these tutorials, but I'm not sure. Yeah, I'm not sure. There's an effort to do an on-prem cloud presence that I am not personally involved with, but the folks at Sizzle are leading. The specific example that we encountered for that is that folks often want to host interactive visualization, and right, so make a website or something where you don't just have like a static plot of your data, but actually let people pick different variables and then plot that interactively. So you need somewhere to host that. So hopefully the on-prem cloud can be a solution for that. Can probably be a solution for a lot of different things. Machine learning, using, figuring out how to use those resources, those tools effectively. Yeah, I'm trying to think. Yeah, so it's interesting. Yeah, what you observe about being so recent. I think a challenge, another sort of overarching challenge is, hesitancy to change the language of analysis. And we really saw that a lot. We're continuing to see that a lot with NCL to Python. And then I think, folks get discouraged when they think, oh, well, maybe we're just gonna have to learn Julia, in 5 years. And so I'm trying to have conversations and shift my mindset less around like the specific language, but developing a community that would then put us in a better position if we have to evolve again in the future. But that's been a real challenge of like getting people to not get so easily discouraged by having to learn something new and losing that sort of support structure.
Interesting. Do you run into any kind of data harmonization challenges? Like, one thing that I've noticed too, given the climate data is way more predictable and streamlined than ecology data or species level data because it's diverse, distributed, different formats. Like, do you find those types of challenges too, or is most of the discussion really on kind of the back end after data's already there?
No, I think we do. I mean, we have those challenges with even just the gridding of different models and ocean model output, regional model output versus, and I'm speaking as a climate modeler, again, that's only one sort of facet of what NCAR does, but yeah, it's definitely not the same as challenges with observational data that can be sparse and unstructured and not gridded, but yeah, in terms of translating between different grids and interpolating data, I guess we see a little bit of that.
Is your community embracing or resistant to large language models in their work and using chat to help code?
I think people are, some people are embracing it. I often forget that I can use ChatGPT to like ask a question about Python. I actually have a slide that you might be interested. Hope I put this in here. Yeah, so I was inspired by, we had a talk at our land model meeting about someone who was experimenting with how to use ChatGPT more effectively for some of the land modeling. And so he had prompted with the question on the right, which is, what's the name for this variable in this model? Which is like, oh, you could find that eventually, but you might have to like do some digging into the code or the documentation. And the answer was spot on. And then for this presentation, I was trying to, I know I had heard anecdotally how many lines of code were in CSM, but I couldn't remember. ChatGPT didn't know the answer to that, right? So yeah, I think we had a nice discussion after this, the land modeling example of being careful about interpreting the results. I mean, there was even some discussion on, can we use large language models as a first pass through questions that come up on the CSM discussion boards and sort of use it to capture some of the low-hanging fruit questions and leave the more complicated questions for the humans to respond to. But again, you have to be really careful. So I think people are open, but also cautious.
Sort of a similar question for AI generally, with sort of people who have been modeling for a couple decades and have differential equation models that they trust and they know mechanisms behind all the things. How is that community responding to the idea of moving to ML or AI to do basic modeling or to be understanding basic science?
Yeah, I think it's mixed, and I think it helps when we can have discussions about physically informed neural networks for representing some parameterizations. And all the work on interpretable and explainable AI, I think is helpful for that discussion too. So it's about building trust, right? I think that people are in sort of different places with it, but those are two things that I think will help maybe bring some more folks in to the discussion. Because yeah, you absolutely have to do it responsibly, and you can, test your black box models, but how to understand what they're actually doing is really important.
How's that playing out? Is it sort of like young researchers are coming in and trying it out, showing that it can work in particular ways, and then people, sort of how is the tension playing out in the organization? I'm curious.
Yeah, I guess I was speaking more broadly about the machine learning for climate modeling, which is not just NCAR, but I think a lot of people are trying it out. Yes, it's coming up more, I think, for grad students who are interested, and it's coming up more in terms of the courses that they might be taking. But we just started a machine learning interest group in my lab at NCAR, and it's got pretty good cross-career stage participation. I think people really want to understand, even if they're not using it, they want to understand the applications. They see it from funding sources as a priority. So yeah, I think it's coming from a lot of places. Any other questions? Yeah.
Yeah, I'm curious, other than what you mentioned about using some alternative language and not the kind of open source community stuff. Have you run into any other challenges or solutions as far as dealing with when you start talking about open science and software development, then you get open source and it's very not inclusive historically. So I'm curious what challenges and or solutions you've run into for dealing with that guy mess.
Yeah, well, language matters, right? So trying to be more intentional and just be as down to earth as we can about inviting people to participate in events. And sometimes that really takes, I think, one-on-one conversations and talking to people who you have established relationships with, work with already. Because I do think, there's this impression that you have to be a Python expert or a coding expert to come to some of these events, and we want to try and get away from that. But I just do think it takes like slow kind of building trust and leveraging your existing connections. So that's, again, trying to spread out across the organization and have maybe point people who can, know folks in their lab who might be interested, but have an impression or, kind of be intimidated. Yeah, it's a hard problem, but that's how I approach it. And also trying to lead by example in terms of just responding to questions on Zulip, even if I think this might not work at all, this might be a wrong answer, but I'm just going to put something out there, and hopefully that gives other people the encouragement or the empowerment to do that as well. It's a good question.
How many hours have you all logged on your office hours?
Oh, yeah, good question. I don't know off the top of my head. Yeah, the data that I was looking at went back maybe a year and a half. There's maybe it fluctuates a lot over the course of the year, but a couple of appointments per month, maybe 5 to 10 appointments per month. I don't know how long all of them last, though. They could be, 20 minutes or they could be an hour. So yeah, I'm not sure.
And those office hours are primarily for folks internal, like who are working on different teams at NCAR, UCAR.
Yeah.
Do you offer anything that's more public facing, like folks that want to learn how to use your models? Could they come in and talk to you about how to do that kind of thing? Or is there like a mechanism in place set up for that?
Yeah, well, there's lots of tutorial resources for different models across NCAR, WRF, CSM. Those are kind of maybe annual or semi-annual things. But this move towards, with the CSM tutorial, the move towards a Jupyter book has also created a permanent online resource for the CSM tutorial, which I think is very powerful because you can go through asynchronously the tutorial resources and you don't have to attend in person.
Yep.
Yeah, I'm trying to think. And then, just the Zulip and the forums are open to anyone to attend and ask questions. And again, it can be kind of broad. So if you're interested in like a specific model, it might be good to try and approach find those tutorial resources specifically rather than like the broader analysis community. Yeah, happy to connect or answer any questions if
Cool.
we can.
Yep.
Yeah.
Thanks everybody for coming. Thanks for
Yeah.
the questions. Yeah.
By the way, I'm Allison. We're the ones who got up lunch. And I think there's several people that are gonna go to lunch and see down in the cafeteria, so stick around afterwards. Thank you so much for coming.